For this example, let's look down here at the bottom where it says refer to example 4 concerning the mean sales per month for the same computer game but sold with 2 package designs. Test at the 1% level of significance whether the data provides sufficient evidence to conclude that the mean sales per month of the 2 designs are different. Use the critical value approach. All right, and let's notice we have a different test statistic for these 2 small sample sizes. All right, but I left this information up here for our example 4 that we did because, of course, we can go back and rely on some of this information rather than redoing some calculations. Let's first, though, state our null hypothesis and our alternate hypothesis. Now, our null hypothesis is going to be that there's no difference in the sales of these 2 package designs. So up here, I'm going to put H0 is that mu1 minus mu2. If there's no difference, the average sales when we subtract them will be 0. All right, but notice that we want to tell whether or not they're different. So if they're different, it's going to be anything else but 0. So that means our alternate has to be mu1 minus mu2 is not equal to 0. So let me insert that not equal sign for us. Not equal to 0. All right, now let's notice we have 1% level of significance. And this is a 2-tailed test. So we need to go we need to go 0.01 divided by 2 is 0.005. This is again a two small samples, so we're going to have to find our critical values as t-values. Our degrees of freedom are n1 plus n2 minus 2. We actually found that in our last example, and that was 15. So our degrees of freedom were 15. All right, so with that in mind, let's use the t function in Excel. We'll have t.inv, and we want 0.005 with 15 degrees of freedom. Oops, I forgot my equal sign. Which gives me negative 2.947. Now remember, this is a 2-tailed test, so we also have positive 2.947. So our rejection region in this 2-tailed test will be anything to the left of negative 2.947 and anything to the right of positive 2.947. All right, so with that in mind, let's do our test statistic. Now, since we've already done the prior example, we can save ourselves some work. Let's look at our test statistic. We actually already did the pooled variance in the last example. There it is right there, 129.33333, so we don't have to do that calculation again. And we've actually already done this bottom part and this part right here already. So what we've got is that our test statistic t is going to be equal to x1 bar minus x2 bar. Well, we did that up here. It was 52 minus 46. It was 6. All right, so on top we're going to have 6. Our d sub 0 is what we've got right here in our null hypothesis. So it's 0, and it's almost always going to be 0. And then we'll divide by the square root of the pooled variance times 1 over n1 plus 1 over n2. Now the truth is, up here, when we were doing a confidence interval in the last example, notice that that is almost all of the right side of the confidence interval. And when I did my calculations, I left the t of alpha 2 over out, and here is the square root of the pooled variance times 1 over n1 plus 1 over n2. So we can just borrow that number from right here. We're going to have 5.771753 on the bottom. So let's take in our calculator 6 divided by 5.771753 and see what we get. That gives 1.039545525, but if I round it to 3 decimal places, it's going to end up being 1.040. Now let's notice that that is in between these two numbers, so it is not in the rejection region. So we fail to reject the null hypothesis. All right, so let's make our conclusion. There is not enough evidence alpha equal 0.01 to reject the null hypothesis. There does not appear to be, running off the page here, to be a difference in sales for these two packaging designs. Okay, now while we're here, let's look at this test using the p-value approach. Remember, if we're using the p-value approach, we are not going to do the critical values right here. We're just going to go straight to this test statistic. And since this test statistic is positive and we have a two-tailed test, we're going to look this up. Whatever we get as our probability, we're going to subtract it from 1 and then double it. All right, so let's look this up. We need to use t distribution though, since this is t. All right, so we're going to use equal t.dist, and that was 1.040. Our degrees of freedom were 15, and this is true, and that gives us 0.8426. All right, so we're going to take 1 minus 0.8426, and that gives us 0.1574. We then want to take that and double it. So that times 2, that gives us 0.3148. So our p-value is 0.3148, which is clearly larger than alpha. And of course, when a p-value is larger than alpha, we fail to reject the null hypothesis. And the only thing different is that instead of stating alpha, we can state our p-value, which is really large, and we, of course, still fail to reject the null hypothesis.